everyone, so here is another video for our first lab, but this video is going to concentrate on our second activity, which is focusing on scientific notation and conversions. So this is kind of our first little practice with numbers. Scientific notation I find to be really important, not necessarily just with science or with oceanography, but even with things that we encounter in real life, right? So like, when we're talking about military budgets or something. So we have $768 billion in budgets. Technically, when we're saying 768 billion, that is also meaning that there's a lot of zeros at the end of that. If we were to actually write out that number, there would be a lot of zeros. But when we say it, we don't say 768,000,000,000,000,000,000, right? That's like, ugh, no one likes to do that, right? It's a little bit too much. So we shorten things up a little bit to make it more comprehensible for us to digest, right? So, we're going to get a little introduction to that, and then also we're going to do several conversions throughout later parts of the semester, so I wanted to just have a sort of introduction to that as well, just to get some practice, okay? So let's have a look. So here we are, kind of our first little intro into scientific notation. You can read this little blurb here, but the first thing I want you to do for this activity is to look up the mass of the Earth and expand it out of scientific notation. So when you Google mass of planet Earth, it will likely say like 5.6 times 10 to the 28 kilograms or something like that. So you would actually physically write it out with actual numbers. So it'd be like, you go from 5.67 times 10 to that little caret, by the way, is indicating the exponent, to the 26 kilograms is the same as, you can kind of write it out. 5, 6, 7. Okay, so the number in the exponent here simply means how many spaces you're going to move that decimal point over. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26 kilograms, right? That's not the actual number, so don't use that. But that is, just an example of how you could do that. Then I have another little thing here looking at metric units. So we have a little table here of numbers out of scientific notation, what they look like in scientific notation with the exponents, prefixes that we use for them, various units are kind of like the subscript for that, if that makes sense, and then an example of something maybe you've heard of before. So then what you are going to do, we scroll down just a little bit more. Here's the questions I want you to answer, right? They're in the light blue. You're going to convert each number here in the left column. You're going to start here, and you're going to either take it into or out of scientific notation. So notice here, like 6.75 million. So you would expand that out. You don't have to fully write it out like this example here. I simply do that because it's a little bit easier for me to visualize. I'm a super visual learner, so I like to have it that way. And then rank, I'll explain that one in a second, but then what you can do right after that is go right back up to the table, be like, okay, so this is to the exponent of 6, 10 to the 6. So 10 to the 6 is associated with mega. Woo! There we go. So then my prefix would be mega. So once you've put all of these numbers either into or out of scientific notation, then you'll refer back to the exponent and rank them that way. So what I mean by that, like say the exponent, this one's 10 to the 6, say this is 10 to the 12, say this is 10 to the 4, 5. So then, you would just like we do 1, 2, 3, 4, 5 from lowest to highest, same thing, but just looking at the exponents. Taking into account that some of these exponents are going to be negative, meaning that the number is smaller than 1 but greater than 0. All right, and then you'll notice that you have 3 blank rows here, and I just want you to come up with your own examples. So you'll just kind of type out some numbers and call it a day, either into or out of scientific notation. Then you'll either convert it into or just expand it out or into scientific notation, and then the prefix that would be useful for that. All right. And then, so that's just like getting us into tune with the numbers, and then a couple of questions here. When and why would it be scientific notation be useful? You can think of things that may not even pertain to science. And then, and that's, maybe just some real world things. And then how would it be useful in terms of your major or perhaps one of your areas of interest or hobbies? Like say if you're into finance, if you're doing finances for somebody, instead of saying, okay, you have $1 million in the bank, or you have 1,000,000,000.000.00 dollars in the bank, you'll say 1 million, right? So it's just able to shorten the terms there. Next thing I want you to do are conversions. So some of us may have learned conversions or how to do conversions in different ways. Basically, this model here is what I was taught when I was in high school chemistry, and it's something that was really, really useful for me. And this is typed out. I'm going to also write it out so you can kind of get an idea of what I'm feeling here. So let me just go ahead and make this bigger. Hi, hey, hello. So say I wanted to go from 5 kilometers to, in this case, I think it was, what was it, miles. So in 1 mile, or sorry, I totally had it right here. So there's 0.6214 miles in 1 kilometer. So this is how I physically have it written out. So I do it as like a T-table. Sorry, the light behind me was making that a little bit more see-through than I was anticipating. So 5 kilometers, whoop, and in 1 kilometer, there's 0.6214 miles. So the reason that we set it up this way is so we can cross out our units that cancel, right? So in our numerator versus our denominator, my kilometers cancel out. So then we're left with miles, and that is the unit that I wanted us to convert to, right? So when we do 5 times 0.6214, 5 times 0.6214 is equal to, and you can round, I think I say round to the nearest tenth. So this is technically equal to 3.107 miles. But if I round to the nearest tenth, that's just that one spot after the decimal point, that would be rounded to 3.1 miles. 3.1 miles would be the rounded value there, okay? So you don't have to stop at miles. Say if I asked you to go from kilometers to feet or kilometers to inches, right? Our number would get bigger and bigger and bigger, but you can look up those conversion rates and just simply continue on the table here. So say I wanted us to go from miles to feet. So in 1 mile, there's 5,280 feet, I think, if I'm recalling correctly. I'm using my memory of Remember the Titans for that one. But you can just add on to the table. Our miles would cancel our miles, and then we'd be left with feet. And then you would just multiply over or divide if needed, if there's anything in the denominator there. Okay. So say if I wanted to do that, right? So I would do that times 5,280. So then 5 kilometers is equal to 16,404.96 feet, which we could round that up to 16,404. Well, we'll round that up to 405, right? Because if we round, remembering our rounding, we round the 6, round that up to a 9, well, then that 9 turns to a 10, and so we would be then rounding to 6,405 feet. Oh, always include your units. Units are super, super important, right? So those are just some examples of how you could go through and do conversions. I ask you I think to do 3 conversions for this one. And please, big note here, pay attention. One of them, I asked you to go from kilometers to centimeters, and I don't give you a conversion factor. And that's because that's using the metric system. And so if you need to look that up, that's no big deal. But it's a very easy, simple, either using 1,000 or 100, and then just kind of going from there. Okay? So with that, do show all of your work. You will not get credit if you do not show your work. And I will be sure to go over these answers in the future when I return. Okay? Thanks so much for watching.